Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are in Algebra 2, Chapter 6, Day 3, logs and their functions. So before we start talking about logs and their functions, we need to understand what a log is. We also need to understand what the inverse of the log is and why we're dealing with logs right now and what the purpose is. Okay, so ideally, we are going to start a new page. That's what we're gonna do. Okay. So I know, and you know at this point, because you're taking Algebra 2, that 2 to the third power is 8. Now, if I were to find the inverse of this particular thing, because this is considered an exponential piece of information, the inverse of this exponential piece of information is a logarithmic piece of information. What do I mean by that? In the past, when we talked about rational square roots, we did inverse functions. So, for example, we did x squared now became the inverse is the square root of x, right? X to the third, now the inverse is the cube root of x. And we were able to graph these functions, and we saw that they actually reflected on the y equals x line. So in here, these logarithmic functions are the opposite or the inverse of exponential functions. So what does it mean, right, that we're going to change this around into a logarithmic function? So here's one thing that I want you to understand, and maybe I don't know if taking notes at this point is a good idea. Maybe just listen for now and then like re-listen in order to take the notes. So we really have three things. We have the base, we have an exponent, and we have a solution, okay? In a logarithmic function, we are going to have the same information, okay? We are going to have a base, an exponent, and a solution. However, in the logarithmic function, these two are going to switch places, okay? Meaning, I'm going to have log base of 2. See how the 2 is the base? The 2 is still the base. But now it's going to be log base 2 of 8 is going to become 3. Your job as an Algebra 2 student is to be able to go backwards and forwards between from exponential to logarithmic and from logarithmic to exponential. Okay, what does that mean for us right now? So I have in the very first page, rewrite the expression in exponential form. So this is already in logarithmic form, so I don't want it in logarithmic form, but I do want to notice that I still have three things. I have a base, right? All of these three have a base. And then all three of them are going to have what's called an exponent. And all three of them are going to have what's called a solution. Okay, so if I were to go from, sorry, I need a different color. If I were to go from logarithmic form to exponential form, I'm going to say 7 to the third power is 343. And we know that to be true because we can do 7 times 7 times 7. And even if you can't do 7 times 7 times 7, you can put it into a calculator and do 7 times 7 times 7, right? That's not the issue. The issue is you want it in the right order, okay? So the first number will always stay first. It will always be the base. It's the exponent and the solution. Those are the ones that are going to change around, if that makes sense. Okay. So in here, I'm going to have 3 to the exponent power, right? So these are my exponents. My exponents are at the very end in the logarithmic functions. So 3 to the negative first is in fact my solution of 1/3, right? 6 as the base to the 0 power is in fact 1 because everything to the 0 power is in fact 1, right? Okay. So this is going from log to exponents. What about going from exponents to log? The process does not change, right? I still have a base for all of these, right? And we know this to be called the base way back when from like maybe course 1 or even elementary school when you were looking at solving expressions or numeric expressions with exponents, right? We know that the big number is the base and the little number is the exponent, right? So here my little number is the exponent, my little number is the exponent, my little number is the exponent. Now I chose these three problems in particular because they have funny things happening to them. We could have just as easily chosen simple, basic, 2 to the third is 8 situation. But I want to make sure that we get through problems that are like a little bit more challenging so that when you are at home doing these problems for homework or getting ready for a test, you're seeing some more challenging things. Okay. And frankly, I think this is as challenging as it's going to get in Algebra 2. Okay. So then I also have in here a solution. And remember, we said that we're going to always flip-flop the exponent and the solution. Every single time we set up a logarithmic function or a logarithmic expression, I'm going to go from exponents to log. The exponent and the solution are going to switch. The base is going to stay the base. So in here, I'm going to have log base 5 of 1/25 is -2. Here I'm going to have log base 49 of, 7 is 1/2. Log base 125 of 5 is 2/3. And you could technically take these, like this beginning portion of each of these logs, and even put them into the calculator and push equals, and you'll verify that they do equal -2, 1/2, and 2/3. But you could do that later, or pause me, whatever. Okay. So now here we're going to say evaluate the log. Sometimes they're going to ask you to evaluate the log and it's going to be super easy and you're not going to want to whip out the calculator and put things in. It'll take more time. For example, I know the answer to this is 7. Is 2. I was looking at the 7 when I said that. It's 2 because I know that technically this equals x. And I can go in and I can change this logarithmic function into an exponential function. Now, let's say you don't know that from the get-go. Sometimes they will say, like, evaluate the log without a calculator. So okay, whatever. We're going to make pretend it says calculator. Now that you know how to go from logarithmic to exponential, it's going to be really helpful for you to be able to evaluate functions that are a little bit more funny like this. Okay, so I know 7 is going to be my base, right? So I always know that my base is going to stay my base, right? I always have this as my base. I also know that my exponent is always kind of going to be my solution, right? So this is going to be that solution. Whoops. This is going to be that exponent right here. And then I also know that my solution and my exponent flip-flop places, right? So technically, I know that these two are going to swap spaces. All of these two are going to swap spaces when I go in to find my exponential form. So this is going to be oops, that's a weird looking start to 7. 7 to the x power is 49. I know from doing math for however many years I've done math, and you know from doing math for however many years you've done math, that 7 to the second power is 49. So therefore, I know x equals 2. Now, because I've done so many of these problems, I can just look at it and be like, oh, I know it's 7 to the second power is 49. So now let's take a look at this one. So 3 is going to stay my base. My exponent is going to become x, and I'm going to have 3. I know that it's only 3 to the first is 3. So there's only one possible solution for x to be 1. Okay, then I have 1/2 to the x power is 1. Now in the previous page, we said that anything to the 0 power is going to be 1. That must mean that this is x to the 0 power, or x is the 0th power. So when you're evaluating a log without a calculator, all you're doing is flip-flopping or inserting an x and then flip-flopping the exponent and the solution, and then solving for the variable. Once you have the answer to the variable, then you're golden. You've solved the problem. Okay. With a calculator, depending on the calculator that you have, sometimes you could just push, log base 7 of 49 equals and call it good. Sometimes you'll have what's called the change of base formula. So this is actually not something that shows up. I don't think it shows up yet, but I think it's important to have a conversation about. So on typical middle school calculators, not the graphing calculators, okay? So the calculators that are outside of that, you can't simply put in log base 7 of 49 equals to get the answer to. Okay, you would have to change this around because on your calculator, the only thing that you have available to you is log base 10. Okay. Um, Log base 10, it's a base 10 system. We know that it's 10 to the whatever power. That whatever power tells me how many zeros I have. So this is kind of like what we're working on here. We're going to take log base 10 of 49. So the big number on top dog, right? Something, I don't know about division. There's my elementary schoolers always tell me top dog gets the something. That's what happens in division. I can't make pretend to understand these new little quotes. Okay, so log base 10 of 49 divided by log base 10 of 7. And then once you push this into the calculator and you push equals, you should get the answer of 2. This is known as the change of base formula. It's not necessarily something that you have to memorize. It's just kind of intuitive, right? So when you have log of a to the b and a is not 10, you can then go into your calculator and do log base 10 of b over log base 10 of a. And you don't even have to push the 10, it just automatically exists. And then you'll push equals and then you'll get whatever answer you need to get. Blah, blah, blah number. Okay. That being said, let's take a look at simplifying. Yeah, it's okay.
Okay. Sorry.
I paused it.
Oh, good. Okay. I totally forgot.
Okay.
Do you know if you have a answer key to these? I mean, if not, it's fine.
I don't think so because it's Allie. I never had answer keys for her.
Oh, okay. That's okay.
I almost never.
Oh, okay.
Do they need an answer key?
No. Like I can do it. It's just like I'd have to do the problem like to confirm 100% that it was right. I mean, it's fine. I know how to set it up, so it's whatever. I already know like this one, and I know how to set it up. I was just wondering if you already had something. Okay. It's okay.
Do you want to, but like after you're done with it, just leave it here and I'll maybe make a copy and I'll make an answer key tomorrow or
I already
later
found
this week?
I found some answers online like already
Okay.
in random things. I just have to like search.
Okay.
Again, I can do it. It's just like
Yeah.
I'll have to solve it then. Okay.
Yeah. Okay, so now what we're going to do is we're going to simplify. So there are certain things, and I know you're looking at problem 4 probably, and you're going to be like, oh my gosh, what is this E? Why is there another exponent? Why is there another letter? What's going on? Have no fear. We will talk about E shortly. However, I do want to say there are a couple of rules specifically for simplifying logs. So the first thing that we need to know about logs, and you know me, I love going out of order, so we're going to start with that. Number 3, anytime there is an exponent to the log, what's going to happen is that exponent could actually be in the front multiplied by the entire log. So I'm going to take x times log base 2 of 64. Now, when they're asking me to simplify it, they're saying that this actually has a solution. So in my mind, I'm thinking 2 to the what power is 64. And I know that 2 times 2 times 2 times 2, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 36, times 2 is 64. So that gives 32, sorry, and then 64. So that gives me 6, it's 2 to the 6th is 64. So really, this entire piece could just be translated into x times 6 or 6x as a final answer. Okay, if that was too quick, go back, rewind, slow me down, re-listen, and then come back and we'll do number 2 together. Okay, so let's take a look at number 2. Number 2 also has an exponent in the problem. So I'm going to take this exponent, I'm going to put it out front. So I'm going to have negative 3x times log base 7 of 7. Log base 7 of 7, I'm thinking in my mind, 7 to the what power is 7? Well, that's just 1. So that means I have negative 3x times 1, which is just negative 3x. That's it. I'm not going any further than that. Okay, next. In here, I know that it looks a little fishy. There is a property that says when you have a base and you have a log to the same base or of the same base to a specific number, your answer is just that specific number. Essentially, this whole bit here gets canceled out, and your solution is the solution of the log, if that makes sense. Meaning, if I had this problem in here and I had, um, whoops, I had 2 log base 2 of 64, my solution would just be 64. This would all go away. So in here, I'm looking at all of this, and because my two bases are exactly the same, my solution is x. Okay. With E is a little bit different, but not so much. When it comes to E, we are looking at this ln as a natural log. There is, I always forget his name, but he is, I believe, if I'm not mistaken, a Swiss mathematician, Swiss or French, I can't remember. And he came up with the letter E, and E is a natural number. Um, kind of like pi, stands in place for 3.1415, blah, 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 right? E stands for 2.71828 or 2818, and something like that. It's a natural number. It shows up in nature very, very often. And because it shows up in nature very, very often, what's happening is it becomes a natural number. So E is known as the natural number. So the reason why we have ln is because ln, and let me remove some of this stuff because I feel like I need more space for writing. Um, so if E is the natural number, then if I have log base E of something, I should have the natural log of x, is in theory what I'm saying. So this natural log translates from French, or into French, I guess, as logarithm naturel. And I'm not writing all that out, okay? However, because I lose the letter E when I'm reading this, This logarithm natural, this natural log, doesn't need to have a base. So I know that ln is the same thing as log base e. Why is this relevant for problem 4? It's relevant for problem 4 because I can actually rewrite this as, and let me actually change my color so that we have a difference. E to the log base e power of 20. And then I go in and I have this whole business here that can cancel out, and my solution will just be 20. So we want to make sure that we understand that e is a natural number, that also if I have log base e, it's the natural log of that number. And instead of writing natural log or log base e, I'm just writing ln. Okay? So anytime you see ln, it's a log, it's just a natural log. We know that there's a base. So now we're being asked to find the inverse. And whenever we look for the inverse, that's when we like swap out the x and the y with each other. So we're flip-flopping the x and the y, meaning I've got x equals 0.3 to the y power. I would like to rewrite it in the form that we've been seeing it, like this 2 to the third equals 8, so that we can change it very easily into a logarithmic function. What do I mean by that? Typically, when you see 2 to the third is 8, that's a weird looking 8, you know that you're going to go log base 2 of 8 because you know that your solution and your exponent are going to flip-flop equals 3. So I'm going to take my solution and my exponent and flip-flop them. So I'm going to go log base 0.3 because the base always stays the same of x is y. And this is the inverse of this, where I flip-flop the x and the y, and then I solve for y on its own. Okay. In here, because I have ln, that's a natural log. A natural log can be replaced with log base e. So I'm going to have log base e of 2x, which really means I'm going to have log base e of 2x equals y, which means I'm going to have these two, the whole 2x and y. Sorry, before I do that, I'm going to look for the inverse. I'm going to flip-flop the x and the y. So I'm going to have log base e of 2y is x, and I want to solve for y. So I'm going to have e to the x power because now my solution and my exponent are going to switch. And then I'm going to divide by 2 to get y on its own. So I'm going to have e to the x over 2. Now, I know that some teachers teach it a little bit differently. That's totally fine. You don't have to follow these same exact steps. You can go in and solve it a little bit differently. I do want to show you what that means on how they solve it differently so that you're on the same page as them in the classroom. So if I have y equals ln 2x, they flip-flop this. So they go x equals ln 2y. And then they e it. I don't even know like what the proper term that they use in the classroom is, but they e it. And so essentially they take it and they say e to the x power is e to the ln 2y power. And we know from the past that this is essentially going to be crossed out. And we know that it becomes e to the x power is 2y. And we need to eliminate the y, the 2 to get y on its own. So you're going to have y equals e to the x power over 2. I think the process is the same in length. I don't think there's like that much more steps in one versus the other. But I do think that you need to understand one or the other and then go with that, like that process. So pick whichever process you want and then go for it. Okay. This one would be the same exact way. So we're going to go ahead and because it's an E, we're going to, well, first we're going to flip-flop the X and the Y. X equals E to the Y minus 4 power. I know that I'm going to ln both sides, if that makes any sense, or go from exponential to logarithmic form. So log of base E of X is Y minus 4. I know that this log base E is actually ln. So ln E is Y minus 4. And then I'm going to go ahead and add 4 to both sides, and that's how I'm going to get Y on its own. Natural log of X plus 4 inverse of this. Same business here. I'm going to go ahead and I'm going to replace the X and the Y. So I'm going to have X equals 13 plus log Y. I'm going to subtract 13 on both sides. X minus 13 equals log base Y. I know that this log has a base of 10. So any single time you see a log and there's no base, base 3, base 7, base 1/3, base whatever, it's always base 10. If there's no number, it's 10 because we are in a base 10 system. So we're going to go from logarithmic to exponential. So I'm going to 10 it, I guess. And then this will cancel. So I'll be left with Y on this side, and this will be 10 to the X minus 13 power. So exponential form is the inverse of logarithmic form. And that is the end of our day 3 in chapter 6 section. And I will see you in the next video. Bye.